4.1, apply triangle sum properties. We're going to classify triangles two ways, by sides and by angles. A scaling triangle is a triangle with zero congruent sides. We can go ahead here and we can do something like this, and we can call this 3, we can call this 6, and we can call this 8. Okay? Doesn't matter if it's obtuse or acute. A isosceles triangle is a triangle with two congruent sides. Notice I'm using some shorthand here. So it could look like this. It could look like this. An equilateral triangle, equilateral meaning sides, is a triangle with three congruent sides. And again, we could have one about that big, and we could have a bigger one. We could have it like that. We could say that this is 9, 9, and 9 if we wanted to. But again, those are equal sides. Moving on in terms of angle classification. An acute triangle is a triangle with three acute angles. Again, notice some shorthand there. Okay? So again, you know, kind of a standard one here that they all appear to be acute there. A right triangle is a triangle that has one with one right angle. Okay? Can look like this. Oops. Could look like this with 90 degrees. Okay. An obtuse triangle is a triangle with one obtuse angle. Okay. And again, it could look like this. And again, obviously, obtuse, we could put like 131 degrees if we wanted to there. Okay. And an equiangular, equal angles, it's a triangle with three congruent angles. Could do it like this, show congruent marks. We could do it like this, 60, 60, and 60. Okay. Now moving on here, being asked to go ahead and sketch and properly mark and label the described triangle here. Okay. An obtuse isosceles triangle ABC with the vertex angle C. So, obtuse, isosceles, and the vertex angle of C, which means C has to go here, and A and B can go here. Equilateral triangle, or equilateral, equiangular triangle with a perimeter of 12. So 12 sides divided by 3 is 4 centimeters each. Equilateral, equiangular, and I could go 4 cm, 4 cm, and 4 cm. All right. And again, I could have marked it with markings like this as well. All right. Part of this is determining on a coordinate plane what a triangle is as far as classification, in this case by its sides here. So I'm going to go ahead and find this measurement here, which is the P to O distance. Distance formula, the change in x is 1, The distance along there is 1, so 1 squared. The change here is 2, so 2 squared. That is 1 plus 4 is the square root of 5. If I'm going to go ahead and find from P to Q, I'm going to do a similar process here. From here I go 1, 2, 3, 4, 5, 6, 7. So 7 squared plus 1 squared. 49 plus 1 is square root of 50. So right now I can only be isosceles because I already have 2 different sides. And now I have OQ. And OQ is going to go 1, 2, 3, 4, 5. Wait a minute here. 1, 2, 3, 4, 5, 6. Okay, that's 6. So 6 squared. Here I'm going to go 1, 2, 3. 3 squared, so that's 36 plus 9 more is going to be 45. So what is this? This is a scalene triangle. Now we're going to go into a couple of theorems now. In the triangle sum, which you may have heard of before, the sum of the measures of the interior angles of a triangle is 180 degrees. We did an activity on this in the formal lesson here. Acute angles of a right triangle, so a right triangle is 90, so the acute angles leave 90 degrees behind, so those would be complementary. And that's a corollary of this theorem, so it's kind of a side theorem to this, so to speak. So keeping this in mind, so if I want to find x, I'm going to take 180 for the triangle sum, minus 125 minus 20. So that's going to come out to be x equals 35 degrees. Okay, over here, this is a right triangle, so these two have to be complementary. So 2x has to be 90, x is 45. Okay. And over here, this is a right triangle as well. I could do this maybe the long way to say that x equals 180 for the total, minus 90 minus 35. That's going to come out to be 55 degrees. Now we could have solved this one like we did with the B problem there. Finally here we have the exterior theorem for a triangle. And again here the measure of an exterior of a triangle is equal to the sum of the remote interiors or non-adjacent interior angles. So let's go ahead here, non-adjacent interior angles. So what that means here is if I have this triangle, and this is x degrees, and this is 70 degrees, and this is 95 degrees, so x is going to equal 70 plus 95. And now using this, we can go ahead here and say that y equals 70 plus 88. So y equals 158 degrees. So that's one way. I can go ahead and find this angle. I'm going to call it angle 1. So the measure of angle 1 equals 180 minus 70 minus 88, which means the measure of angle 1 equals 22 degrees. And then if this is 22 degrees, and I know those supplementary angles, so 22 plus y equals 180. I subtract that 22 over, we get 158. So again, two different ways to find that. And then finally, find the measure of angle 3. Well, first of all, angle 1 is going to be 180 minus 65 minus 45. So the measure of angle 1 is 70 degrees. Then I know that these three angles add up to 180. So the measure of angle 2 equals 180 minus 70 minus 45, which means the measure of angle 2 equals 65 degrees. So this is 65 degrees. And now finally, I know that angle 3 has got to be, measure of angle 3 equals 180 minus 65 minus 20. So that's what, 85 taken away, so this would be 95 degrees. So final answer, the measure of angle 3 equals 95 degrees. This concludes our notes and practice for section 4.1.